Good morning, engineers. I'm going to record a work solution to one of the questions in the document that I sent to you and then leave you to answer question 2 by yourself. Okay, so let's start by reading the question. A simply supported beam of length 1.25 meters is designed to support a uniformly distributed load. This is the uniformly distributed load here, which actually stops part of the way down the beam, with the ability to support a further point load L in the overhang. The support reaction B is given as RB equals 26 newtons. Okay, the question says find the load that can be supported at point C. So let's start off with a principle that moments about A are equal. In other words, clockwise moments are going to equal the anti-clockwise moments. That's important because the beam is in equilibrium. It's not turning one way or the other. This simple support here wouldn't be able to support a moment anyway. Okay, so let's work out what the moments are. We've got the weight at a distance. Well, we need to work out what that distance is, and it's halfway through the uniformly distributed load, half a meter. And because it's 40 newtons per meter, it's 40 times 1 meter equals 40 newtons. The other forces acting on the beam are the reaction force at B, which we're told is 26 newtons, and this load here. Okay, now we can start to calculate the moments. We've got a moment which is going to be going clockwise of 40 newtons times half a meter. We've got another clockwise moment, this one here, which is the load times 1.25 meters, and that's going to be balanced out by an anti-clockwise turning moment of B, and that acts at 1 meter. Now we know that this is 26 newtons, so I can substitute it in there and then solving my equation for L, I'm going to get L equals 4.8 newtons. Okay, let's have a look at the second question. The reaction force at point A when L is applied. Now, this time I need to take moments about B, and I'm going to say that they're equal. This is slightly more difficult because B is not at one end of the beam, so we're going to need to pay careful attention to get clockwise and anti-clockwise worked out correctly. So distances now are going to be calculated from B, not from the end of the beam. So let's work out what's happening. Well, I've got a clockwise moment here, which is L times half a meter going clockwise. I've got this one here that's actually going to be going clockwise as well, and that's A times 1 meter. And then I've got an anti-clockwise moment here going in the opposite direction, making it turn in an opposite direction to the other two, and that's 40 newtons, the weight of the beam, times half a meter. Working this out, I've got 0.25 times 4.8. Remember that I worked out L in the first part of the question, plus A equals 20. Working that out, I'm going to have A equals 80.8 newtons. Now, just as a bit of a double check, the forces that are acting down on the beam is 40 newtons plus 4.8 newtons. The forces acting up on the beam are the force at A, which was 18.8, and the force at B, which is 26, which also balances the forces acting down. Okay, I'd like you to have a go at question 2 from the document that I sent you. Email me with any questions and email me your solutions.